Perfect. Well, I know it's been, well, a couple of weeks for some of us because of SEG and the Mira event and other things like that. Yeah, so we can get caught up on some of those things and maybe even a bit of an update as what was the last meeting that some of us would have missed. So, Joe, would you like to start us off?
Yeah. So at the last meeting, we ended up talking about more of the EM1D stuff and kind of deciding, like, at least talking about how we were going to get that in. From what I remember, essentially, I've been working towards that as well as trying to get what I've worked on into GeoAnna, and then using GeoAnna inside SimPEG EM1D. As I was doing this, I kind of had a few questions as I was looking, because it's basically, I'm also doing a kind of a code review of the SimPEG EM1D stuff at the same time as this, as I'm doing this. I had a few questions for Dieter, actually. I was looking at doing the lagged convolution for the prediction, or for the transform. Because right now what it's doing is it's just doing the normal digital linear filter, the angle transform, where it's essentially computing, you know, a bunch of lambdas for each single point, right?
Yeah.
So I was just trying to look at how it was doing that, and the issue that I ran into is that it couldn't really, like, the lag convolution seems really dependent on the orientation of the source and receiver. Like, there's that AB and angle factor part of it.
But that is the same for all. If you use the normal filter or the lagged convolution.
Right, but as I was looking at it, like in the digital linear filter, as I was looking through the transform and the operations, like, it didn't seem like it. The way we were using it was, we didn't pay attention.
No, it's just if you do the thing is how it goes into the kernel is if you do the normal DLF type, then it's a matrix, because each frequency has a whole bunch of each location has a whole bunch of wave numbers.
Right.
And then if you do the lag convolution, then you have just one array. And then when you come out of the kernel in the transform, you have to reshuffle that and interpolate it so that then for the actual DLF, each location has the array of lambdas it needs.
Mm-hmm. So what I from what I was looking at as I was looking through your code, essentially, like, that reshuffle thing just kind of like copies a part of it and moves it, it like kind of goes like this down through that array.
Yes.
Like, it goes like it just kind of shuffles it by one each time as it turns that into a full matrix of solutions, right? Like
maybe
that's what it looked like it was doing, from what I saw. But it was still just kind of like the angle, the way we were using that out angle, or the angle factor.
Yeah, the angle factor is because for the whole EM1D case, if you have the inline, you know any angle, right? Because that's just, at least in the formulation, I don't know if it's for Ward and Home the same, but I guess it's the same. Then it's just a factor, the angle. So if you know y0 x anything, then you know the whole plane.
Yeah.
And that's also done outside the kernel. That's the reason. And even outside the transform, I think, if I remember right.
But like I said, the way we were using it was, or the way that was being used in EM1D was like, they were not providing any angle factors. Just, I think everything was essentially being done ahead of time.
Because
J0 and J1.
Yeah, well, could be. I think the only thing I looked at Soki as was loops, horizontal loop. So there is no angle factor because it doesn't matter, right?
Yeah, it's radially matrix. So
yeah,
like that.
That's why we never implemented that. Or I think the Bessel function that has the angle factor in it is 0.
Right. And the ones we were looking at though also had, Devin, I think you had added in the X components and Y components for sources and receivers as well.
Yeah.
So those were the ones that would have like an angle dependency, right?
Yeah.
Yeah, but like, I guess as Dieter said, it's sort of like you're shifting the problem, solving it, and then just, yeah.
Yeah. I just, like, it seemed like the way it was doing it, like there were no angle factors on just the Z component, ZZ, but we were also we were using the same transform, the same angle, like the same, AB to do X, like the X components and the Y components as well. So I wasn't sure if that was completely correct.
Yeah, that is fine. You can do the angle factor in the frequency domain.
Okay.
Yeah.
I guess the other thing is that when I was playing with the tiled, or with the lagged convolution part of it, I wanted to be able to like give it a list of, have it repeat over frequencies. So if I had like the transform for a bunch of frequencies, I wanted it to be able to like, because it was only able to do it for one frequency at a time. If I had if I had the same operation for multiple frequencies and I wanted to do it, repeatedly, the way it worked, only work for one frequency at a time.
Maybe that's also the implementation, because the kernel in EMPyMod, you can do it for an arbitrary number of frequencies and offsets and layers all in once. So that might be also how SimPEG EM1D and EMPyMod is connected at the moment, a limitation.
Okay. But either way, like I was trying to get it to use the lagged convolution because it's so much quicker, right? You don't have to do it with so many transforms.
Basically, it's like one offset and maybe a little bit more, but yeah, it's the price of
Yeah.
What was the current implementation, Joe? Like, were we using? I thought like we were just using the regular Hankel FHT. Is that what we were using?
Yeah, you're just using that. So what ends up happening is that you have to do a transform for every single observation point.
Right.
Like a full transform for every single observation.
No, I think Sogi used the interpolated version, no, with certain points per decade.
Yeah, I think so.
So it wasn't, but we discussed it. I think it's several issues, and we said we should go for the convolved version -1.
That one was for time transform. I think that accuracy was for time.
Yes.
Was for time transform, but I think what Joe is talking about, that spatial.
Yes, but then you have to be careful, because if you come from the time domain, you shouldn't do the convolutional in the frequency, because then you have to loop over offsets anyway, and it's going to be more costly than if you do the standard Hankel.
Right.
So this is only worth it if you want to have frequency domain data, not if you want to have time domain data.
Joe, what's sort of your concern? I think it's in general, the current structure is basically is like for a single transmitter, you got a single datum. Well, not multiple time channels, but still it's a single receiver in a sense. We could do, I think Devin expanded to have XYZ.
Yeah.
So yeah, if you can compute everything together, that would be better. But is that what you were concerned, like a kind of inefficiency issue of kind of doing that process?
Yeah, I wanted to make it, I was still trying to get it to go faster as far as the not having to compute so many lambdas.
Okay.
Yeah, ideally I wanted it to be like, okay, well here's, ideally I wanted it to be, okay, here's a source, here's for, you could give it a bunch of receiver locations. As long as they were all at the same height, it would work just fine.
Yeah, that'll be nice, because yeah, you're right. If the height doesn't change, it's basically same. So I don't have to recompute.
Even if the height did change, I think we could use the lagged convolution operator. We would have to take out part of we would have to kind of modify some of the internal code, or just use the parts that we needed. Because the only thing that the lagged convolution does, right, it takes the output and then tiles it for each input, or for each it takes the frequency or the wave number solution, right, and it tiles it for each observation point, shifted by 1. So that after it does that tiling shift by 1, then we could apply the.
But the kernel is the more expensive, no? If you change the height, then the kernel change, so that the transform itself shouldn't take a lot of time.
The observation height, what looks like it's just a function of.
Yeah, but I think if you change the height, your I probably need to double check, but I guess your that reflection coefficient changes, I guess, depending upon.
It didn't.
No, the reflection coefficient won't change.
No.
Is that right?
That's because that's just a property of the Earth. There's a term in.
It's like an exponential decay with height.
Yeah. There's just the one term with Z. It's just the e to the So I guess I sort of saw that there's kind of like 2 applications of this. There's sort of a right now it's slow, but it's generalized, and it's kind of, let's say, for academic use where you can
trying to keep it.
we'd like to keep it generalized, but there's obviously
a much faster
massive speed up if all the offsets were the same. Like if you were doing an airborne survey, there's massive savings.
All the offsets are the same. It's just I'm just trying to avoid calling the kernel function for every single observation or receiver point every single time.
Oh, for sure. I think there's definitely a lot of stuff that could
even though like I did make the kernel function faster, I'd still like to avoid calling it when I have to.
Yeah.
Great. Joe, I'm glad that you're actively working on this, and you guys probably don't recognize. I think actually, Joe, we wrote that Fortran code in C, and generalize it that it can handle like a derivative of chi, derivative each height, like a thicknesses.
Yeah.
So yeah, I'm very happy, and it's actually quite faster. But as Joe said, yeah. It's great. So it sounds very complicated, but at the end, we're going to have a great product.
Yeah. So I guess if I understand the sort of status of this package right now, we're still sort of actively optimizing it, making it faster. There's some pretty significant improvements we want to make before we actually bring it into SimPEG.
I would say that. Yeah.
Okay.
That's what I've been actively trying to figure out here. I'd really like to get the lagged convolution thing. And just like I said, there's the 2 issues that I kind of saw was that the whole tiling operation that is done within that DLF wouldn't
could
work.
maybe have a meeting once and discuss it.
Yeah.
Then it becomes clear to me, because I have to look at it again as well. I didn't remember.
So Joe, at the end, what you're trying to do, because suppose you got 10,000 sounding location, okay?
Mm-hmm.
And then that's where you want to benefit from the lagged convolution, or you're thinking about basically single sounding, and you potentially got multiple receiver location for a single, like a.
Yeah, I'm thinking like single sounding, multiple receiver locations.
Okay, I see. Yeah, that makes sense, because I thought like once you have a different sounding location, it doesn't quite make sense, because like now, like how current structure like that tiled code is, or whatever global code or stitched code is, it's completely separate operation.
Right.
Okay. So one interesting use case is like it's a large loop, but multiple receiver. What we've recently done is a drone TAM. So you put a receiver on the ground and fly a drone and have lots of receivers. So I think that's kind of case where you can really benefit from that kind of an idea.
I guess what I've kind of thought about this point is I'll keep going ahead with the current way that it's formed, because like you said, Sagi, it doesn't really make too much of a difference if it's just single source, single receiver every single time.
But I mean, still, it's great to have that.
With all of this work too, do you think, it sounds like there could be a really nice paper just specifically about sort of SimPEG EM1D, talking a bit about the code optimizations, all of that, and then maybe a couple nice use cases. I mean, it would be great if we had, you know, a compelling synthetic and a compelling field data set. Is that something you kind of have in mind as a bit of a goal, or is that something we can put on the radar? Because I mean, this is a ton of work, so it would be good to make sure you get some mileage out of it beyond just it being extremely useful for the community.
Well, I think the synthetics are already done. So I've got about 8 to 10 tutorials already for everything from like the stitched stuff, FEM, TEM, forward simulation, inverse, the whole suite of everything is actually in tutorials already. But an actual field example, I think, would be the missing piece for that.
Yeah, but I think it also takes a bit of thought to sort of think through, like, what would you want to include in the paper? Because I don't think that you'd want to include like everything that we would do in sort of tutorials and documentation. That needs to be there by the time the paper is written completely. But I think, you know, we can pick sort of 1 or 2 sort of high impact examples. So it might be worth,
I agree,
you know, starting a Google Doc and sketching out a few ideas while this is on the radar, or if you need a break from coding.
Yeah. So Joe, one interesting example that I was thinking was Bupunong. So what we have currently is the Resolve and the SkyTem acquired at multiple times. So there's a 2-year interval. Actually, Dequan and one of our case studies sort of handles that. But I think there's an interesting case where you can invert them together and see how much changes have made. And the current that 1D stitched structure is kind of nice, dumping everything into a single inversion and then all of them together. See if there's a changes. Anyway, it's just it's because like what we have developed is actually done, right? Other people already done it. But I think there are a few ways we can sort of make it a cool example and also talk about the technical aspect of how we optimize that. I think we probably need to weave it together well, because we're just talking about the code. It's not very exciting because it has been done for a while.
Right.
But, if you weave things together right, I think there could be an interesting paper that can write.
Yeah.
Yeah, it would definitely help if you can line it out a bit so I understand better, because I think it's mainly an interface how we talk to each other now, how we implemented the DLF in SimPEG EM1D, because I think you can do most stuff at once. You can do arbitrarily a number of offsets, offsets, and so lambdas, arbitrary number of frequencies and arbitrary numbers of layers in one go. So that should be possible, but I think it's not all possibilities are enabled in our implementation.
Yeah, so Dom, we will add the capability of inverting the susceptibility. So Joe developed the derivative, so we'll add that, and probably.
And it's kind of fun. Like I kind of showed the code to Saki really quick. You kind of naturally had the derivative to susceptibility as you were doing the derivative to everything else. Like it was just like one of the steps that you had to do. Like, oh, well, there it is. Might as well save it.
We were just not acting on it. Is that the we're not just taking a step on it? Is that the idea?
It's just naturally part of how you derive the derivative in this manner.
Okay. Looking forward to see it, man. It's used quite a bit, so it's important.
Just to kind of give the idea of like the speed up, as I was testing the kernel, the forward operation is essentially the same speed. The inverse or the calculation of the kernel or the sensitivities to the kernel was about 10 times faster.
Oh, wow.
Wow.
And at the same, like I said, at the same time, you got all 3 sensitivities at the same time.
Wow. I'm thrilled to test this. So usually what sort of the size of the inversion that I'm running is about 20,000 soundings. And I'm using usually 16 core. Takes about 3 to 4 hours to run the, I don't know, 20 iterations or 30 iterations of one unit to finish the job. Yeah, so if the sensitivity is the most expensive part, so if you can reduce that to, I don't know, 10 times faster, it'll be really fast. So I'm thrilled to do this.
The sensitivities are not recalculating between at each CG iter, right? It's stored and just applied as a matrix. Is that right? Is that correct?
It is stored in this case. So it's like, yeah, you're not going to have that much improvement in like compared to regular like a PDE solve where you need to compute J every time when you're solving CG. But still, huge improvement though.
That's really exciting, Joe. Do you have any other updates or things you'd like to chat about?
I'm pretty sure I've gotten the discretized to what I would like it to be. Again, it's still, when we push it, it's going to break what's in SimPEG right now because there's a few things in there that are relying on those shape-like properties to be NumPy arrays, where this will be something that we want them to be tuples, or I want them to be tuples at least, so they're not modifiable. And yeah, so they will, that does break as I run through the tests on SimPEG, but that's the only part that breaks. So we might need to put we'll probably have to put a maximum discretize dependency on SimPEG right now, and then do a quick pass over it to go catch those parts where it's using it like that. Yeah, I've gotten, I think I pushed the release notes to that branch as well on there.
Yeah, they're looking great. Quite extensive, but they're looking great.
Yeah.
That's exciting, Joe. So what do you need for that? Do you want folks to take a review, or are you happy with where it's at and want to hit merge?
I mean, I'm pretty happy with where it's at. Like I said, I've been using it with SimPEG, the only errors I found was those kind of errors. Like it all imports just fine. It all starts up just fine. It's just when you start using it, it breaks because of that assumption. That's the only thing. Like I was, okay, I purposely wanted to do that, and I tried to put a warning there that this will cause code to break. And this is intended, right? So that part of it's a little bit scary. It's just like, so well, as soon as I pushed that, like the only reason I have been a little bit hesitant to merge it is because I still have no idea what's causing that SimPEG error on testing. And
segmentation fault error?
Is that segmentation fault? And I'd like to, and I want that passing so that when we updated it, it'll disseminate on through to everything.
Oh.
Still, like I just need to devote like 2 days to figuring out what is going on there. Because it's really annoying because you kind of have to I can't reproduce it locally. So that means I have to push a change to it and then let Travis test it.
I think there's some ways that you can actually log in to a shell on Travis potentially, which might speed up some of that. But yeah, debugging CI.
I kept trying to get the Docker image that Travis uses to test the environment. And I got something close to it, and that still didn't even reproduce the image or pre-produce the seg fault. Okay, that's about all I got.
Okay. Thanks, Joe. Well, that's plenty.
Sorry, 20 minutes later.
No, that's excellent. I mean, I think these are important updates for everyone. So you can.
Somebody's actually working. That's great.
Exactly. Exactly. Cool. Dieter, would you like to go next?
Yeah. Not much from me. What is that is the misfit as it's going to be implemented in EMG3D in the future. It's going to be very similar to the standard one as well as the same as in EMG3D. It's going to be very similar to the one in SimPEG. We first had a misfit from the paper, from the plastics molded paper with the adjoint state gradient. But yeah, that was a misfit that had at the same time a offset weighting, a frequency weighting. Well, the data weighting included that. So it wasn't just the standard deviation. It was a complete complicated function, which kind of made it hard to compare to anything. So we go back to 1 over standard deviation. Yeah, which will make it easier to compare it to SimPEG, and maybe even if we once get GeoSci.xyz implemented, that it would be the same. Yeah. Other than that, it's mostly the 3D paper that I just want to get away. So I'm not spending any more time, but that I think shaped up nicely. Excited to see what the reviewer's gonna say. And yeah, otherwise SimPEG wise, not much.
Well, thanks for pushing us on the. Oh, sorry, were you gonna?
I just wanted to add what Dieter was mentioning about the sensitivity kernel, like what from EMG3D. It's currently considered the data as a complex value, whereas what we're doing is dissecting that into real and imaginary. But I think, Dieter, what we're doing is basically still kind of doing considering a complex value when we're solving. At the very end, we're sort of breaking that apart to real and imaginary. So
yeah,
I think we can still do the exactly same thing in your code, I guess. We just need to be kind of careful when we're sort of breaking it apart and when. But,
exactly. Yeah, I think that's so it's going to be the same if because I'm going to have to give it in as a complex source, the residual, to back propagate, and then it comes back as a gradient, and then you just have to be careful that we give the same weighting, so that the real and imaginary that is stored in SimPEG together gives the same as the complex in my case, sort of. Yeah. Yeah. I think it's mainly terminology and definitions, but it can be very confusing.
Absolutely. Dom, would you like to go next?
I can. I spent a fair amount of time this weekend looking into the clients of Dask, right? So currently the way we're doing it is just a direct compute, which implies that it only works for a single machine. And I found some pretty important efficiency gain if we start using clients. Because mostly it has like a scatter function to be able to maintain data on the threads and all that. And we had a major bottleneck when you start using the tiling on the CG solves. So I basically rewrote the CG as a Dask version, so that we're basically doing all the iterations in a single graph instead of like going down the iterations. And it looks like it makes a huge difference. John, you probably remember, right? Seeing the cycles of CPUs going up and down during the CG solves, and that's just because of that, right? We had like highly parallelized like derivative 2, but then we're going after this into single threaded part and then kicking back again. So by basically mapping the entire CG as one task, we now have like full efficiency on all the processors. And then using clients also opens up the possibility of being able to spin computations on multiple nodes, right? Because technically we just need to submit workers' IP addresses. So I think that's the way to go. I'm going to keep testing it. I'm running like a series of inversions right now using the old method and the new one. It looks right now, at least I have a 2x faster, and memory management is a lot nicer too. So that's what I spent time this weekend. And then reviewing Devon's, you submitted some changes. Good catch on the error of the potential fields. I think we should still try to not do logical indexing. If you can go away with arguments, just thresholding the arguments, that'll be better. But that's it. Yeah.
Yeah, I guess I don't want to arbitrarily add a small tolerance because I mean that's the action of just like shifting all of the data over by a little bit. So
Yeah.
I'd like to do something that actually recognizes if the locations are over a node or over an edge. So if you've got a more clever way to do it, that was just the easiest.
But I
But
mean, what's the issue with just adding a small constant? Would you basically want to kick it out of the floating point arithmetic errors, right?
It ends up being like really bad because you have some terms that basically you're going to be dividing by almost zero.
No, but that's the point of the small constant.
Yeah, but if you start shoving them in there, I mean, the errors over the nodes were like 15%.
No, I know with the old
Yeah,
implementation that it sucked,
yeah.
but if you could try to just add the epsilon on all the arguments instead of doing the logical indexing, because logical indexing is gonna be costly, right?
Yeah.
And it's like a numpy operation. It's not sure how that's gonna handle that. So I think if you could
Okay,
stick
yeah,
to the
yeah.
epsilon, that would be good.
Yeah, I mean, I'll play around with it because I mean, I guess, yeah, if it's off the node or off the edge, then adding a small tolerance is really not going to do very much. So I mean, really, I can play around with some tolerances and try it for some cases. And if
I tried to change on my side, Devon, and if you make sure that you apply it on all the args, you know, the way that John rewrote it, a bunch of args, right? So just add the epsilon all on this alone, and then that seems to solve it on my side. So try it on your side too.
Yeah. Okay, I'll play around with it a bit. But yeah, I guess I want to add a small tolerance near the beginning because when you put it on that many terms, you get this propagation and accumulation of error in every computation that you're using, and that sort of did us in.
So just for my understanding, what was the problem that was encountered?
Oh, I might be able to. Well, yeah. So when you're doing the mag forward problem, if the observation location is over an edge or over a node, you have some terms in it that are like 0 divided by 0.
Okay.
And analytically, those terms would cancel out, but numerically, it gets angry. And so when I compared the UBC code with the SimPEG code, the SimPEG added stability by adding tolerances to make sure you were never dividing by 0, but it propagated error through. Whereas the UBC code being written in Fortran, they actually they looked and found, oh, I'm over a node or I'm over an edge, I'm not going to use this term. So it is 100% analytically accurate. So what I've been doing now is playing around with a way to keep the SimPEG code quick, but also make it stable. And right now, the solution has been to look for the locations that are over nodes and edges, and then add some kind of shift them over a little bit. It's kind of a loose way of putting it, but it means that I have to go and index and look through all the locations that are over edges or nodes. And Dom is saying that would have implications with parallelization. So trying to find that balance or find a solution that will keep the parallelization efficient, but also give us that level of numerical stability. So, I mean, if you want, I can bring up the comparison now and plot it. I don't think it's too necessary, and if everyone understands what's going on. But yeah.
How often would there be an operation where it's divided by almost 0? Is that once or many times? Could it be taken care of there? That's basically the question.
I mean, I'm sort of,
if it's not close to 0.
Yeah, I guess I'm looking, because we're generating the sensitivity matrix once. So I guess I'm doing this as we define the sensitivity matrix, like as we construct that matrix. I don't know if that answers your question. I mean, in practice, I think it's pretty unlikely that that you're going to be having a large amount of your locations actually be above edges or nodes. This is something that's, if somebody does a synthetic, they're going to potentially do, it's actually pretty likely that they're going to be doing it unless they decided to put them at cell centers or over cell centers.
I guess, is it in discretize? That's my first question.
Oh, no, it's in SimPEG. Yeah, because it's not like a finite volume. It's an integral solution, and it's getting constructed within SimPEG. And so we're doing a parallelization, I think, to each row can be constructed independently. I think that's how the parallelization works.
Thanks for that. I appreciate the overview. And Dom, I don't know if maybe in a couple of weeks or whenever it makes sense, if there's a bit of a demo or something like that, a bit of a walkthrough that you'd be willing to give just to sort of get us up to speed on how the client implementation with Dask works. I certainly would appreciate that, and I'm sure others might as well.
Yeah, I was hoping to be able to show you some some graphs, but my computer is still running it. So next week I can show you. Yeah, basically showing the difference between old implementation over problem size and over number of tiles, right? So if we increase the tiles, ideally we'd like to be able to decrease the computational time, but that's not what we're seeing with the current implementation. The total sensitivities, time is reduced, but when we go to the inversion, it's basically the same. It takes the same amount of time as the tiles increases because we're getting into inefficiencies. So hopefully that fix will improve that.
So Dom, is it kind of specific to sort of like a Mac problem where you store the sensitivity, or would it be general, like for PDE code where we're not really kind of forming J, but kind of giving a function that kind of able to evaluate either JVAC and JTVAC?
Well, if your JVAC, GTVACs are not Dask operations, you're not going to see the effect because Dask will stop at every JTVAC and do this operation in line. But this is really it's going to be a gain if for instance, the hashn is a stack of Dask operations, and then this is a series of those into the CG. This is where it's going to shine, right? Because now the whole thing is just one big graph that Dask can chunk through.
So for instance, let's say we break apart the DC problem to a multiple domain.
Exactly.
Parallelized with Dask. And then that could be the case where that could benefit from the implementation.
100%.
That's where I'm currently kind of headed towards there, Soggy. With Dom there, we're just kind of breaking it up and hopefully being able to do that.
Yeah.
And then with the beauty with the clients is that now for instance, the direct solvers, right? I'll need multiple machines. We will test it, but we'll be able to spin the direct solves on different nodes. We just need to figure out how this is done, right? Do either we submit a misfit function to a client, or I'm not too sure at that point, but it opens up the potential for that.
It's exciting.
Yeah, Dom, I can definitely supply the network if we want to test that out. For sure.
Yeah, do you work with multiple IP addresses? How do you,
Yeah, we have it set up for that. Right now, I'm not really onto that, but yeah, it's already set up, and I was just going to try and start doing that. Yeah, we have about 5 computers that we can just kind of give it the IP address and just spawn off problems.
Oh, perfect. Sounds good. I was wondering where I would be able to do this, but it makes total sense.
We can make that happen for sure.
Yeah, let's talk when we're at that point.
Nice. Yeah.
That's really exciting, Dom. It's very, very cool. John, do you want to go next?
Yeah, sure. Yeah, I've been actually fighting with the MT a little bit more here. Yeah, it was going good for a while with the impedances, and then this last project, they're looking to do like a really low frequency, like 0.2 hertz to about 1,000 hertz, and they want to invert it over all of them. And the impedance is it's just failing, it can't. The range in the data is just too much. So I've been looking at implementing resistivity and phase. So I talked to Devin there, and Devin pushed me in a good direction. I have it almost implemented, just pretty much all on the receiver side. And I had added another receiver as a complex resistivity for the resistivity in phase. And since we're pretty much, like, we have all that stuff, all the calculations done in the impedance, we just have to use all that information to kind of construct the resistivity and the phase. But yeah, I was kind of stumbling at the adjoint part. So when we use JVec, I don't know. I think I've got something going here, but I was wondering if there's anyone I can maybe bounce the math off, or someone who can, or how do I test this kind of thing to make sure that it's okay?
Sean, your sort of goal is changing the data type into apparent resistivity and phase? Is that what you're trying to do, rather than real and imaginary the impedance? Is that what?
Yeah, exactly. A lot of people that I've been, like, a lot of the MT processors and stuff from other, yeah, that we've just kind of hired, they've said that this problem is usually solved by going, like, if you can't do it with impedance, the range, you can solve over larger ranges with the resistivity and phase. So that's what's kind of leading me to it.
But what's exactly the problem? Like, I'm kind of not sure why, let's say, having like a big spectrum of impedance is a problem.
Well, the honest truth is I don't know what the problem exactly is, other than it seems to be the range of data. Like, if you go, like, for the UBC example, the L shape, which is like 10 hertz, 50 hertz, 200 hertz or something like that. Yeah, it works fine. Everything is really great. But if you go into the low frequencies and then with high frequencies combined, if you just even look at the data, the low frequencies are like just super small, and it'll try and fit that, but it won't even like attempt to fit the larger data, the larger amplitude data.
Is that a multi-dimensional? Is that like, how have you tried 1D? Is that still a problem?
This is all on 3D. Sorry. Yeah. So I was using just X, Y, and X, or sorry, X, Y, and Y, X, the off. And yeah, most of the time that was the solution. Like, just having the XX and the YY, that was kind of tough. Like, having all the components in there. So just breaking it down to the off seemed to be working great on the smaller frequency ranges. Like, the ones that I ran before were they were either like 1 hertz to 30 hertz or something like that. So now that I'm going into this wider, like, couple decades worth, yeah, this is
what strategy did you use to assign your uncertainties?
So this one, or recently, I'll go by frequency, and I go by, what else have I done? Oh, I guess it was by component before, but I'm not doing that too much anymore. So now I'm just doing like a floor plus percentage of the data kind of thing.
Yeah, well, I guess the question is, how big is that floor? Like, what's dominating? Because for the off diagonals, then you really want the percent to dominate.
Okay.
And the floor to be really minimal. And I mean, you can kind of see that the off diagonal components sort of correlate to your resistivities. And so if you put a floor that's too large, then you will be overfitting resistive structures at the expense of conductive structures.
Yeah, that makes sense.
Yeah.
Yeah, but again, I've tried to do low as well. Like, I've tried pretty much throwing everything at it, and it's just not functioning right now. Yeah, but no, that totally makes sense, because that's pretty much what I was seeing is if I crank up that floor, then it's going to fit that resistive thing. Or you put a weird resistive piece right at the top that makes no sense, kind of thing.
Jean, did you figure out how to take the derivative of phase?
Yeah, actually. Well, that's why I want people to check the math. A little bit.
Yeah, I'm more than happy to help. I think I actually kind of struggled at one point, because we wrote this 1D code, and initial goal was actually having both real and imaginary, and the amplitude and phase.
Yeah.
I think it's actually discontinuous, that phase. So I had a hard time actually taking the derivative. Because if you think about, there's a phase wrap. So it is a discontinuous function. So you need to be careful when taking the derivative of the complex, like a phase of the complex value. But I'm pretty sure there is a solution. I'm just not 100% sure of what that is.
I just kind of thinking about it. I mean, it just kind of, I mean, I don't know if you have to concern yourself with that as long as you just, you know, do a phase shift after you do a step or something, you know?
And Joe, you're right, because I think it doesn't matter, because if that's constant when we're taking the derivative, it's gone. So I guess it should be fine. But yeah, anyway, I had actually, I tried a couple of things and it didn't work. And so I kind of didn't.
Yeah.
Yeah, well, I broke up the pieces here, and I don't know, it seemed to have went through. So I'm testing it right now to see how it does. Well, again, yeah, I also need to know how to better test it to make sure that it's working.
I think the issues that I had, like when I'm starting like trying to invert phase or something, if I ever had to do I mean, it's never happened, but I was also inverting for like angles and stuff. If you're inverting for angles, then it kind of gets weird if you have like, if it kind of goes over that jump there, that cycle.
Yeah.
It's weird, like a spatial smoothing on that is weird. But I don't think there should be too many issues with taking the derivative of phase as far as a data point.
And I think MT, it's probably pretty rare, I guess, you see the phase wrap. Yes, it's pretty like a low frequency behavior and large wavelength. So anyway.
Well, yeah, I'll put it out there as soon as I just have one running right now just to see how it goes. And yeah, if anybody can take a look at it, let me know what I did wrong or if it looks okay.
I'd be super interested in taking a look too. So feel free to ping a few of us because I think this is an interesting.
Right, and John, as long as your order test pass, I mean, it's working, I guess. Yeah. So if you have done that, I mean, it passes the order test, then you're good to go.
Okay. That would be what I'm going to have to do next, order. Right now, I'm just making sure that it works and it's giving values that aren't too wild and kind of thing like that.
And the other thing that you can just try is just do a finite difference. So do a finite difference and pass with whatever analytic function that you derive. And if that's matching, it's a good start. And then if that passed the order test, there's a pretty rare chance that your code is wrong.
Cool. All right. Well, I'll do that here next. And yeah, actually, Dieter's given me a hand and hooked me up with some other MT code, Mer 2D. And yeah, so I can do some comparisons. And
cool.
We're going in the right direction with all this. Just have another way to look at it. And yeah, I still want to get on that tiled DC problem, but things just keep piling up. So yeah, that's all I got.
Thanks, John. Devin, would you like to go next?
Sure. I have my fingers in many pies. So I think we've kind of gone over the potential field stuff. And I think, yeah, maybe Dom, you and I can have a conversation at some point and finalize this. The other thing is I've gotten through the doc strings on discretized utilities. So yeah, maybe I'll even just like screen share it for fun just for a moment. Yeah, so I mean, this is kind of how it's rendering now. And so I've gone through, I've followed the NumPy way of doing it. And for all these utilities, I've added examples whenever possible. So some of the functions or utilities were maybe lacking some explanation or they're a little bit confusing. So I've tried to make examples of using all of them. So there's a lot of progress on that. I don't think we need to spend too much time talking about it. What else did I do? There is, Yeah, so I've been doing some of these validations. So comparing the UBC codes to the SimPEG codes, and I've done it for the DC/IP octree. And this motivated, I mean, the validation, but also I decided to come up with an interesting way to plot in 3D arbitrarily. So I actually decided to write sort of a kind of a fun 3D pseudo section plot, because we already go and get the midpoints, but now you can basically feed it in 3 points that define a plane, and it will just go and find the locations that are a certain distance from the plane that you've defined and plot it up. So that was actually just kind of handy, instead of having to take this 3D survey and then you know, you would need a line ID vector to basically decompose it into a bunch of 2D data sets and then plot those pseudo sections. So this was just a way of saying, give me the data that's in this area. And I found it pretty useful. But I noticed that there was a little bit of a discrepancy between the UBC code and the SimPEG code. And I think it has to do with how the sources are being defined, and maybe some interpolation that's happening. I was hoping somebody in this group could tell me, but I have a suspicion that in SimPEG, there might be something that says, take my source dipole, or take my source and put it at the nearest node, or something like that.
Which code are you using?
I'm using DC/IP octree. So, I mean, useful thing with this.
I meant the SimPEG side.
Oh, I think I might be using cell centers.
Yeah, that's the problem. So try nodal and see if you can get the better fit.
Yeah.
The cell centers will put the source at the cell center, whereas the nodal, it interpolates, right, Sagi?
Yes, and also that cell center code in Tensor, it uses the mixed boundary condition, but that's not implemented in the octree code. So accuracy, so what's actually doing that is it's basically putting a Dirichlet boundary condition. So you're going to get pretty bad accuracy in your surface, I think. So at the error interface, what you're doing is saying, oh, it's a Dirichlet, potentially 0. That's the boundary condition imposed.
Yeah. Yeah, I think I tried it with nodes, and I got something that I was also really not happy with. So I'll continue to play around with it, but yeah, I think ideally I'd want to use the nodal formulation. But yeah, I still do feel that the way that UBC code is getting your right hand side is still different than what SimPEG is doing.
That's
Are
true.
Are you doing any are you doing any of the operation that shifts the electrodes to topography?
Yeah, I'm not implementing any of that kind of stuff on purpose, and right now I'm doing an example that doesn't have topography.
Okay. Because I know there's the code that Dom had written to shift the
drape topo or something?
Yeah, that drape topo. It does not only it moves the electrodes to cell centers. It doesn't just decrease the height, it actually moves them to cell centers. And the other thing is if you're doing that cell-centered one, it'll always put it to the nearest cell, because there's not a great way to interpolate cell centers on a octree mesh right now.
Okay.
And it just does nearest neighbor as far as interpolation like that. So that's why it'll always end up at the center of a cell.
Yeah, well, I'm not using that functionality yet, but I guess these are all the things that we're figuring out as we do these validations.
Nice.
But yeah, I'll give it another shot with the nodal formulation and see if there's any discrepancy there. But yeah, I also think that it should be better.
And it would be nice too if you could test Dev to just run the CIP tree by putting all the electrodes in cell center and then compare with the SimPEG, so that we know that the interpolation is exactly the same. We're not like fudging it different way, just so that we can test the raw accuracy of
the solve.
Yeah.
Okay. Yeah. So I can do that. This is just sort of the first pass.
And Dev, can you also do just the half space? Because we don't know which one is right at this point. We probably put more confidence in UVC, I guess. But it'll be nice to actually have some analytics and test.
Sounds good.
I think there's like actually tests in SimPEG that do that.
Well, there would be, I mean, there's tests when you want to merge a branch that you're doing stuff on. I mean, we have the whole host of tests to make sure that we're matching an analytic.
And I think it does a match against some sort of like DCIP solution as well.
That I'm not sure.
Like I remember like it downloads something and it compares it to some solution. I thought it was a UVC DCIP code. You'd have to, I think it's in there somewhere.
Okay, so yeah, maybe I'll do some kind of, whole space cell centers or something like that, and then I'll do this one with nodes, compare it.
And Dev, if you want to play around with plotting, I recommend use a scatter plot of Plotly. Is actually much nicer than using the matplotlib. So you can actually spin the view and select the points and see the values in 3D space.
Yeah.
If you want to spend time on it,
Yeah, I didn't want to spend too much time on it. I just wanted a quick and dirty way of being able to plot up points if you had an arbitrary 3D survey. Because I know that, PyPlot isn't really a 3D plotting package. So,
pretty quickly.
Yeah, it was just something that was quick and dirty, but I think it's pretty useful. You can just select planes and see these things, see the pseudo sections kind of pop out. But sorry, you saying Plotly?
Yeah, Plotly. I can give you a little snippet if you want to.
Yeah, sure. Might as well.
The scatters, yeah.
And I mean, just to wrap up for the last thing that I was working on, I started working on the self potential, spontaneous potential stuff. So yeah, Soggy, I was able to go take a single point charge and match the analytic solution for the either using the Q, the source term, or there's actually an analytic solution for the current density that results from that. And so I input that and also get it. So those three things match: analytic, and then using J source or Q source. So we're in business.
I feel very happy because I haven't tested. And actually, Craig used that code, so I think we're all good.
Okay, so yeah, I mean, probably try and do the test for the sensitivities, all that fanciness, and maybe try and solve some synthetic inverse problem. So yeah, lots of different things. That's pretty much it for me.
Thanks, Dev. Cool. Soggy, do you have any quick updates? Dev, you're still sharing your screen, just FYI.
Oh, sorry.
No worries.
Nothing really. I think I'm not working, I guess. I went to SCG, and it was actually interesting to sit on machine learning. So I had a chance to listen to Boss Peter's talk about talking about what LDATS and Lars is doing. And so I actually was motivated. Okay, well, how do I understand what they're actually doing? So I spent some time on reading their papers, and it seems like actually pretty cool. The architecture they developed, it seems pretty I'm not sure how practical it is yet, but I think there seems a lot of potential. And the structure is very similar to our inverse framework. So I was thinking, oh, can we have a SimPEG ML and basically inheriting sort of what they're doing? Just a thought. But because actually the structure is quite similar, and I think that we can basically use our optimization package to solve training problem. Anyway, just a thought, and that's sort of where I'm moving on next phase here in Stanford, like data integration using machine learning. But I think it seems like they're going in the right direction because the data is sparse, what they're dealing with, and then you want to learn deep. So their architecture seems actually nice and kind of like imitates the physics. So anyway, just like a different direction, and I thought like in general it's kind of interesting.
One quick question on that: would folks be interested in actually starting just like a SimPEG ML Slack channel? Because it would be interesting. I mean, I would enjoy chatting further on some of these papers and things like that. Could just give us an avenue to discuss some of those things. Cool. I see a thumbs up from Thibaut. Do you want to start that?
And also, I was going to have a chat with like a professor in Aarhus. So he's a geostatistician, and he's kind of developing a lot of geostatistical algorithm and doing a Monte Carlo inversion. But he basically needs some sort of geophysical simulator. So yeah, it would be an interesting collaboration, basically feeding him. Here's a simulator that you can use and do whatever you want with your simulation and get some output of it. I think there's like that kind of just providing simulation in these days. It seems there are quite a bit of potential, and that we can increase use of the SimPEG. So anyway, just a few kind of connecting point that I'm trying to make in this case.
Excellent. Thanks, Sagi. Thibaut.
Yeah, I will just be brief. So I've started over doing the merge between PGI and simulation, and I'm happy that finally figure out a way to do it efficiently. And I got like a first example running yesterday. So that's the first step. So I'm gonna be working on that. But then, yeah, after that, I guess like I'm just gonna try the other example. But after that, I guess there will be some. I will create the pull request, but there will be some work for me on documenting my code, and maybe after that also like make it more clear, maybe more. There are some ways like I'm sure can be make more efficient, and also I'm pretty sure that the name convention is not right at the moment. So, but at least I got a first example working. So that was like that's the first step.
That's exciting, Thibaut. That's excellent news.
There was so many conflict. It took a while to sort through.
That's excellent. I'll be quick here because I know we're running a bit over. But yeah, so SEG. Well, I really enjoyed the session that we had on SimPEG. So huge shout out to Dom and John for awesome presentations and organizing us. Especially Dom, thanks, and for also getting up super early, starting at 6 a.m. in Vancouver.
And Dequan, man, Dequan was up for like 24 hours.
Yeah. So for those of you who weren't able to tune in, I really enjoyed it. And so Dom and John, feel free to jump in. But it was really cool to see like such a spectrum. I think this session really brought together like everything from sort of research. Dequan gave a tutorial on using the 3D time domain code, which was awesome. It was a great tutorial and really cool to see that, we've put enough documentation out there and been supportive enough that, somebody else who hasn't been deeply involved in developing the code felt confident to give a tutorial. And it was a great tutorial.
And sorry, Lindsay, and also he gave us, we should definitely follow up, right? He gave us a snippet of how to run the code on HPC.
Yep.
I think that's a great example that we should just connect to.
Absolutely. Yep. I will make a note of that. Yeah, which was super cool. And then both seeing John and Dom's talks connecting much more to sort of industry, user-facing ways to interact with SimPEG. So John was showing the DS. It's Caravel is the system?
Yeah, I think
Yeah.
Caravel.
Caravel. Which is super cool to see SimPEG like wrapped in a GUI and you're launching huge jobs on your servers, which is awesome. And I appreciated the overview of solvers and all the work you've been doing digging into that. I mean, I think that's a huge benefit to all of us. And so knowing you're making some headway there is super cool.
Thanks. Yeah.
And then for folks who haven't seen the Geo app that Dom's been working on, I think that's some of the coolest widget work that I have seen, and like piecing together a like GUI interface in a notebook for inversions. So if you are looking for some inspiration on really cool apps, you should absolutely check that out. The other thing I think
Geo app.
Yeah, it's on the Mira GeoSci.xyz GitHub. We can have Dom maybe drop a link into the Slack. Yeah, it's super cool. And I also really enjoyed, so there were a number of folks who came in who are using SimPEG, and so in particular, Jaja's group is actually using SimPEG quite a bit, as well as Dequan's group. And so I suggested to Jaja, and we should do the same for Dequan, maybe in a few weeks' time, once we're sort of through, catching up after being, at SEG last week, just sitting down with them and getting a better sense of what they're up to, how we can potentially be a bit more supportive. Because like I was amazed to see some of the stuff that is being done with SimPEG that they only reached out sort of minimally for help. And so if there's stuff we can be doing to bring in their work and be supporting them more, that would be cool.
I'm reviewing 2 of their papers right now.
Oh yeah.
They picked me to be a reviewer, so like, oh yeah, I should probably do it. So we can have more papers coming out from them.
That's cool. That also brought up, I think, the important point of we need to get a page on the documentation about publications using SimPEG, cool examples with SimPEG that may or may not have a paper, like GeoApps. We need to get that up and running because there's like some really cool stuff happening that if we just had a space where people can drop a link, we would know about it. So yeah, we can maybe try and give that a go in the near future.
I mean, in some ways, I almost thought that was a bit of a purpose of the gallery we have, right? Is that we wanted to get people showing us some cool stuff that we did and then putting it in the gallery, and especially publish. We had that space for published works using SimPEG.
I think it's a great place to put things, but I think we also want something that's a lower bar to entry, where somebody can basically just copy paste a DOI and say, I wrote a paper, it used SimPEG, and be done. It's because, I mean, it would be great if they then want to go the next step of, making an example, but I think at a minimum, we just want a place where we can catch what people are up to that are using SimPEG. John, I saw you unmuted. Did you have something you wanted to jump in and?
I forgot now. It wasn't even important.
Sorry.
No.
Cool. Okay, so that's the high levels for those things. I don't know, Dom or John, was there anything else you wanted to bring up from that event?
Not really. That's about it. Yeah. Hopefully we got one more person interested. It's like a rock show, right? Supposedly you get one new fan every show. So there we go. Maybe we got one.
Were there like any kind of discussion on road ahead? What's the future? Like, I don't know where SimPEG goes, and that kind of questions or discussion.
There is
mostly with the Jaja's group, right? I think they're still wondering how to contribute. They're happy users and they're tweaking the code, but they're not feeding anything back. And I think there's a little bit of nervousness in showing their code or something. But I think the road ahead in my mind is to encourage more collaboration.
Yeah.
Yeah, there was talk about yeah, how like being from D Mira, how our current contributions, like, are we hoarding them, or are we keeping, or are we making them open? That was a little bit of an interesting conversation too. Trying to promote, you know, even industrial people to bring in their stuff.
Yeah, because both Jean and what's his name at Laurentian?
Or
Forget his name.
Richard.
Richard
Yeah,
Christmas.
Richard. Yeah, they were asking, both were asking the same question, right? So it's something that they are wondering. What's the industry academic who's going to contribute most to the future of SimPEG? I don't know.
Well, and with that, and this is a longer discussion, so I'll just throw the idea out and then we can table that. But I think also sort of with the publications, sort of the conversations around governance, it would be great, I think, to actually also have sort of like industry partners listed somewhere publicly, so that it's kind of clear that like the Mira involvement, the DS involvement are adding value, and it's a productive partnership. And so just throwing that out there, and we can maybe have a chat of what you folks think would be sort of a productive, beneficial both ways way to highlight your contributions and involvement in SimPEG. The last thing I'll say is I'm giving a presentation tomorrow for the SAGE group. And so SAGE, it's mostly like global Earth, whole Earth folks in geophysics with this group. But there is a fair bit of interest, I believe, in MT. And so I'm going to try and have a slide or two on that. So I might ping later today if folks are willing to just take a quick look and maybe add a few bullet points and things like that. It's a short talk. It's like a 15-minute talk plus conversations. But I want to give sort of a bit of a perspective on what we're up to, but then also where we're going that might connect with this community. So I'll ping with some slides later today. Cool. Well, I know we're a bit over, so thanks for sticking around. Does anyone else have last minute burning items? No? Okay.
No.
All right. Well, thanks everyone.
Just give me a shout, Joe, if you ever want to talk about the DLF and I look into it.
Yeah, sure thing.
Yeah.
Cool. Excellent. Thanks everyone.
Have a good day, y'all.